Congratulations to all. You know, a two-day conference such as this one, it can be difficult. There's a lot of material. Time is short. Moving around. Congratulations on making it so far. And I hope this event has been of great interest to you. And we're hoping that the next hour that we spend together will be of interest to you as well. Welcome everyone. The talk and the subject today, I'll make sure I read it properly. How successful will artificial intelligence advancement in machine learning be at preventing cyber attacks? My name is Algis. I am the moderator. I have three panelists here that are subject matter experts, each in their own fields. And let's begin. So we'll ask you to each take your turns to introduce yourselves, your backgrounds, and if you have any particular interest with respect to AI and ML, please bring them up, and we'll have an opportunity to explore these aspects over the next 45 minutes. Please go ahead. You can start the question.
Okay. So, good afternoon. My name is Christian de Boek. I'm based here in Brussels, so this hotel and this city is my garden. It's very comfortable for me to have this PCB conference held in Brussels. I have more than 20 years experience, not that much in security, but far more in continuity and recovery. So what happens when all the barriers, the gates, the protections, and the means we put in place to prevent intruders to enter, finally enters, make some damages, how do we recover? This is my core business, and this is exactly why I'm sitting here, to see what's coming up with artificial intelligence, machine learnings, and how do I keep in sleep at night instead of jumping into recovery, anything that has been broken.
That's a wonderful answer, and a wonderful introduction. All right. Next, please, go ahead, Fatos.
Hello. First, I want to say Masal Khair. Ahmed Afifi, I'm a cybersecurity manager at the National Bank of Egypt. We're here today to talking about how machine learning and artificial intelligence can support the cybersecurity. To keep it easier and in a simple definition, artificial intelligence is we can consider it as the main concept. Machine learning is, we consider it as execution. It is mainly related to algorithms, scripts, and technology, some stuff like that. As the world is going digital, we have to notify that, and as the expert Kevin Mitnick said, people are the weakest chain in the cybersecurity circle. Everyone has to know cybersecurity, has to be cyber aware, as we are all connected. We are all have many devices in our homes. I'm asking my colleague Fatos to simplify it easier. How can everyone is impacted by cybersecurity, by AI?
Well, thank you, Ahmed, and thanks for the rest of the panel for the introduction. Hi, everyone. So my name is Fatos Ismadi. I am from UK, from London. So I work in London as a senior cloud solution architect for Microsoft. I specialize in AI and ML primarily. So I work with all the AI and ML technologies that Microsoft has to offer. I am particularly interested in natural language processing, machine learning operationalization, and the use of these technologies for different various purposes, but one of them is probably obviously cybersecurity, which is why I'm sitting here today. So hopefully during this session we will provide you with some of the applications of AI and ML in cybersecurity. What are some of the key objectives of organizations when they consider AI and ML for cybersecurity, the challenges that we're seeing out there with organizations, and then maybe talk about level set a little bit, maybe to start with, around AI and ML, and how that's pertained, or how that's relevant to cybersecurity. So, do you want to do that now, Algis?
Yeah, let's do that now. I'm going to assume that there is a large part of large percentage among these all of you here, that may not have the more technical background and have maybe more of, a compliance and governance background. So if you may, and anyone can step in. We've already touched when we started talking about definitions or clarifying, differentiating between, what machine learning and artificial intelligence is. But maybe by having it in each their own words. Ahmed, you already proposed something. Maybe Christian, when either from a personal perspective or when you speak with others and those topics of AI and ML, which are buzzwords, right? They're very much in the media today. What are there certain challenges that you see in terms of clarifying what it really means, what it is, and maybe more importantly, what it isn't? Who's willing? Is there anyone willing to go and tackle that?
Yeah, I can start if you want. Right, so 2022, right?
Yes.
So AI and machine learning, I think, so I work with a lot of customers across industries with Microsoft, being financial services, retail, and every time I speak to either tech executives or heads of practices like AI or data science, each one of them has a different definition of AI and ML. And usually it depends on which background and which context you're working in, and the definitions can vary, obviously, based on those things. However, I think there is a consensus, I think, in the tech industry, especially those people that are working in machine learning, that machine learning in itself is a technology, is an optimization technology at the end of the day. It's an ever increasing optimization process that machine learning engineers work to build in the form of algorithms that take some input data and learn from that input data iteratively to create some predictions. And the predictions can be about anything. It could be about whether somebody, for example, has defaulted on a loan or not, or whether somebody is eligible for a mortgage or not, or whether somebody is committing fraud in a fraudulent banking transaction. So each of these can be optimized and can be, let's say, translated into a machine learning problem. Now, where it varies is AI. I think, obviously, you've seen the term AI being used as well in the industry and in the media. And when people talk about AI, they usually infer systems that have the capacity to mimic some form of human brain cognitive ability. For example, think of speech, think of vision, think of language. These are abilities that humans obviously take pride in, and obviously it's in the human domain. So how can we use machine learning techniques to kind of mimic some of these capabilities? And this is where AI kind of fits in. So we are seeing a lot of organizations adopting these services nowadays. Of course, companies like Microsoft, Amazon, Google, they each have to offer services that mimic some of these capabilities in some form, in some level, and some shape as well. For example, with Microsoft, we have seen human parity being overcome in technologies like speech. What I mean by that is we are now more accurate in understanding and recognizing speech. Actually, understanding is not the right word, but recognizing speech better than humans. So we have kind of surpassed human ability in that space. And of course, other firms out there are innovating a lot in this space. I'll pass it over to Ahmed.
Yes, I need to talk about a use case which we are all impacted. After COVID, many companies are going to work 100% remotely. After the pandemic began to decrease, we are going back to office. But there is a challenge, there is still waves of COVID. One of the AI use cases is facial recognition. It could be tracking, have a database of all employees' pictures and facial recognition, using the entire surveillance cam and using a simple machine learning algorithm. And using temperature sensors as an indicator, we are able to track which employee, after that we reported that one staff is began sick with high temperature, we are able to track which employees contribute with in order to isolate them again back to the office by taking footage and then perform the required operation. It helps to make sure the safety for the other. Another example regarding facial recognition, regarding opening our smartphone. Using it capture our our facial biometric, and then it is like authenticator. This authentication can perform many something, starting from opening the phone, in up transfer $100 million by through bank. Simple example can we use also is regarding fraud detection in banking sector. Fraud detection systems in past is only marked fraud or flag fraud regarding on certain patterns, certain conditions. After that, it become into behavior analytic for each user. For example, if you have a credit card and you had more than 1 year, you had never performed a cash out from this credit card, and suddenly there is a transaction occurred. If the bank had a good fraud system, you must have a call within 1 to 3 minutes asking you, is that you perform this transaction, or is it something of fraud? However, it would be likely normal, but it differs than the old learned behavior for each customer. I think Christian can talk about network threat analysis as one of the AI and machine learning use cases.
Yes, yes, indeed. As you mentioned, Guy, AI is very helpful because it's much more powerful than one human brain. So actually, multiple human brains made into one system. They don't get distracted. They can work 24 hours a day. They're quite reliable, they never get sick, they never get distracted, and so they are very useful and effective in detecting any fraud, any kind of trial for intruder to come into your systems. But still, they are mimicking, as you say, Fatos, they are mimicking the human brain, and they are learning from the human, so they're also subject potentially to be spoofed and to be made up, to be put in mistake and to take the wrong decision. So yes, it's helpful. The question is how reliable and how confident are you to dedicate and to give full confidence and full power of decision to your AI for analyzing and taking decision right now. I think personally we are just in the beginning of the journey of AI, so the future will be what it will be, but today, who's reliable, who's giving confidence, okay? I'm fully trusting my AI for preventing hacking, access, wrong authentication, identity, corruption, etc., etc. And who think there is still need to have some countermeasures in place, whatever they are, to be able, in case of a too late detection, what do you do then?
Yeah, please, go ahead.
Yeah, okay. So, yeah, I like the topic. The question, the main question for the topic itself, I like how do you think that AI or machine learning can preventing actually cyber attacks based on social engineering, for example. So something that out of the control, out of the authentication, out of something that going beyond the recognition of it. So the social engineering is something that based on the personal behavior. So how can we think that AI or machine learning can predict or can control the cyber attacks basically?
I will be a very quick answer, and then I will pass to my colleagues because I'm definitely not the specialist of her. But today what I see is, for example, you fish someone and you get his credential and you try to connect on a system or in a way which is not the usual way, or you're requesting special access to a system you haven't accessed. Today, mostly you have two options. Either the approval for a demand of a credential is automatic, you get it because you belong to some group, or it's subject to some human approval. What we see now is more and more based on some criteria, you get the access or you don't. And this is where machine learning can say, oh, this looks a bit weird. Is that people really needing access based on his profile and history, and this is where you have machine learning and AI, but I'm pretty sure you can elaborate much more.
Okay, firstly, I need to elaborate that security is not completed without everyone. Customer himself has the liability and has to be cyber aware in order to protect himself. Of course, institution and entities has the biggest part, but it is not completed without customer himself. Also, it is about a chain. Social engineering, yes, it is the most one of the most sophisticated attack. It is rely on the human behavior and culture, and it differ from one to the other. But if, for example, Christian just say, for gaining access, nowadays you are going to be passwordless. So the way that have a phone call or phishing email to get your password, your username, it will not work in this case. If you have use a password, if we use a passwordless mechanism or two-factor authentication, and of course it will be higher complex if this two-factor using a biometric like a fingerprint, facial recognition, eye contact, some stuff like that. That's the first part. The second one is related to behavioral analytics. For example, if there is a successful social engineering attack is successfully, and then the attacker is going to gain the access, the system itself and as machine learning is go and learn, and it is learning faster actually, will know the actual customer behavior. For example, if you never log into your banking account after 10 p.m. If you do that, it will pop up a red flag, and then it could need the second step of verification. This is just an example. I think Fatos can...
Yeah, I completely agree with both the panelists. I think I would say, as with any other machine learning problem out there, whenever you're facing a technical issue like this, always strive to solve it using non-machine learning based methodologies first. It doesn't have to be machine learning automatically, the default answer is you don't buy into the hype. And let's say, just as Ahmed said, try the mitigation strategies like multi-factor authentication, passwordless, face recognition, all these methodologies. And then see, okay, what are the inputs, for example, a threat actor would use to infiltrate an organization using social engineering techniques. Some of those could be a phishing email. Another one could be just calling the person's organization's contact center and trying to get information as much as possible. So then you look at it, okay, from these inputs, what are the typical machine learning techniques you can use on this type of data? Think about if they were calling a contact center to get information as much as possible. You can transcribe that audio call and find certain behaviorals based on the text that you get from the caller. And then you can use different machine learning techniques to infer what that caller is calling about, where they're going with the conversations. Are they being too intrusive in terms of requiring sensitive information, PII data? So you can capture these type of salient information from just the call transcript, and then you can act upon them. You can build mitigation strategies that can act upon that data using machine learning techniques. So that could be just one example of how you could tackle this.
My question actually was, in the case that happened with Uber, for example, and it was based on social engineering to one of the very technical team. It's not something that, for the non-aware, like based on non-awareness of something. So it's in the case actually it was like happened to one of the very technical team and social engineering, and they have able to access the whole system and they grab all of the information from the side. So this is my question: is where we can see the AI from that point?
As Fatos elaborated, we should fix the non-AI and machine learning first before transferring to it. For the certain incident like Uber, there is many drawbacks, there is many vulnerabilities actually. First one, the security engineer is human at the end. So he may be, but it should very difficult or very impossible to do that, but it may happen. It happens, he is social engineered and the attacker is able to gain access to his authenticator. The second vulnerability is there is no network segregation inside Uber itself. There is none machine learning or AI at all, but it is another network security control. It's not in place. The third one is excessive access that the security engineer had. He had access almost to every device or every connected server, every connected network and security device at the environment, which is totally wrong. There is no identity and access management, and there is no access control on this. So to not to be panicked, it is a layer. It is about layer. Machine learning and AI is one layer for that.
So we've already touched on a few points and a few considerations and examples. We had a little brainstorming session before coming in here. We talked about facial recognition. We talked about fraud detection. Another topic that had come up as part of our little pre-session, pre-panel meeting was the values or added value with AI and ML with respect to implementing spam filters. We had touched the aspect of filtering. I see a natural fit with respect to that, perhaps a little bit more obvious, for me at least. Maybe Christian, you could dabble onto that or add on maybe or complement other aspects.
I pass on this one, sorry. I'm much more as the spam has been successful and what do we do then? So,
Algis, I think we have a question at the front here.
Thank you very much. I think I need to change the question like this. Rather than saying how successful is AI advancement in machine learning at preventing cyber attack, my question is how successful will the attackers to get AI advancement to learn the behavior of the user?
The behavior of?
The user.
Okay.
Could you repeat that question?
Can you maybe pass the microphone?
In sort of anticipating what it is a user would expect to be doing or not.
No, I mean here, thank you. Here the question says how successful will an AI advancement in machine learning at preventing cyber attack?
Yes.
My concern is, what if it's giving access for cyber attackers? The trend of the users.
Yeah. It's a fair question. It's something we were pondering as well before coming here to you all. As with ethical hackers, who will be using today increasingly machine learning and AI to protect organizations and defend them from cybersecurity threats. On the other side, you will have the other party, which will decide to use AI and ML for nefarious purposes, right? So, and these parties will be almost like in a tug of war, right? So one of them defending, the other one attacking. So we will see increasingly threat actors leveraging AI and machine learning techniques to infiltrate organizations, but also build AI and machine learning models to make their attacks more sophisticated. If you think about it, for example, if a model has been deployed by an organization to detect whether a transaction is fraudulent or not, so an organization like a bank could be having a fraud detection algorithm that can detect whether a fraudulent transaction exists or not in the system. Now, an attacker could also build a model that could try to replicate the defender's model so that they can bypass these security checks that the model can pick up. And by that way, they could be, let's say, 2 or 3 steps ahead of the defender, potentially, if their algorithm is able to cope with more scenarios than the defender's algorithm. So these, as I mentioned, these things will be like a tug of war between the defender and attacker, and both parties will use and leverage AI, one for the defensive purposes and the other one for attacking purposes. And it's going to be like this for the foreseeable future, I think. I don't think that's going to change.
Anyone else want to add to that?
yeah, it's a kind of a race at the end. You see, you're in your castle, you try to keep the people outside of your castle and then try to get in. So you're a bit on the reactive part, and this is where AI can help you to keep the intruders away. But on the other hand, they're far more motivated because the money is inside, so they are pretty much motivated to get in and to engage also with AI to enter. So it's a race who has the biggest, the smarter, the better AI to get one way in or to keep you outside. And at the end, who will win? It's the imagination and the power of the imagination of the humans that are behind the AI that will win, probably. And from my perspective, there will still be a risk because we are inside, so we keep our position. We are on the dangerous side, I will say. So still, again, preaching for my own church, you have to develop your mitigation procedures, your recovery plans, your continuity plans. What if your systems have been compromised, and how do you keep working, how do you keep in business in case of, but this is totally outside, and we can have that word around the coffee later on, because this is a bit spamming this topic.
Yeah, but it's very much aligned with the topic that is presented in front of everyone here. Yes, you have a particular notion to bring up, sir? Oh, okay.
And soon you will have a microphone, I hope.
You see,
Oh, yo, sorry,
you have a
please,
question?
go
can I
ahead.
ask my question first, if you don't mind? Yeah.
Yeah, go ahead, please.
So we have both a consultancy and a training division, and every single time we engage with a client, whether it's banking or healthcare or whatever, they all have heard of AI and they've all heard of machine learning. They've also seen a lot of movies, and they all kind of have this weird perception of what both of these tools, shall we say, can do. But I read a document just last week called The Future of Work 2025, and a number of versions of that, and every single one of them states the number one skill set required by 2025 is AI. Yet, when you search for training, it is very, very thin on the ground. Are you guys seeing similar? Are there really opportunities out there for maybe people who are currently analysts to actually move into that field, outside of, say, a university, I mean? Because interestingly, PCB do not generally deliver technical training courses.
Yeah. Me, just as an individual in a similar role as yours, that's the only place where I've seen it is in academic circles, and I know people that have gone into that. Have you folks seen other types of opportunities to build up skill sets in that area?
Yeah, absolutely. I mean, obviously, that's a huge gap in the market at the moment for skills in this space, and not just skills in machine learning and AI, but also skills in leveraging machine learning AI in particular domains. Because what we find as well, at Microsoft, I can speak for Microsoft, is whenever I go and speak to customers, whether that's banking, as you mentioned, health, oil and gas, or telcos, the biggest challenge that organizations face is skills gap, and adoption of AI and machine learning internally. And then it becomes a problem of buy versus build, right? Because if they face a particular AI problem, they will usually, first and foremost, will look for turnkey solutions out there that exist. If they don't exist, or if they're too expensive, then they will look for, okay, how do we get into the skills for that? And then it becomes a problem of, okay, do we hire a consulting firm to do that for us, which have the skills, or do we upscale our internal people in this space? And companies like Microsoft, Google, Amazon, and other smaller companies out there are offering training courses on these, and they're usually free. It's never been more easier to upscale in this space than today. Loads and loads of MOOC courses, like university-type curriculums out there online that are a fraction of the cost of what you typically would pay for, let's say, in-house or in-person kind of training. There's loads of courses offered by Microsoft itself that are completely free and available to anyone out there in the general public to upscale in machine learning and AI. And also not just upscale in AI and machine learning techniques, but also how do you apply AI and machine learning for different domains. And not just training people that are going to be hands-on with AI and machine learning, but also training the executives of the organization. So people that work in C-level suites or people that are heads of practices. So what does it mean for them to adopt AI? How do they do that effectively across the organizations and across departments? So these are all things that we're doing immensely within Microsoft to kind of publicize this training material out there, make sure that people are upskilled. It's in the benefit of not just the organizations that will benefit from it, but it's in the benefit of companies like Microsoft, so that we have people out there skilled in this space as well. So, yeah.
Just don't use those words, free training.
Yeah.
Like that here.
Pretty much free.
Cool. Yeah, and in my opinion, it should be a government direction. Some countries and some big firms, like Fatos elaborated, offer free internship and free courses, free hands-on, in order to cover it. As we are talking about machine learning and AI should solve this gap a little by automating, by going for automation. Automation is reducing the number of the needed stuff, but not too much. But it reduces it to acceptable margin.
Thank you. Yes?
Yeah, well, I have two questions.
Okay.
So the first question is, we've been mentioning AI advancement in machine learning, and you said AI is a war talk, something between the defense and the offensive side, the hackers, trying to have the best algorithm, to defend, the algorithm of the defense side. So what I'm trying to know is, we know that algorithms and are just the translation of what human brains think, what people are doing. Like you and I, what we decide is what the AI is going to translate in an automated way. So which means at the end of it, the result of an AI will depend on the people who are developing that algorithm. So if there is a flaw or if there's a problem in that development process, then there will be a problem with how the AI is going to replicate that. So if there is a flaw, then there will be a flaw in AI. So I don't know if that is something that you guys have come across and see that there was a problem in AI because of the development of the AI itself.
I do have a personal feeling based on what we just discussed today with Ahmed as well. I feel, as you said, artificial intelligence will only be as good as the humans behind that developed and program it. And if you're alone to develop your stuff, you will have your own small, smart or smarter or not that smart, depending on you, artificial intelligence. If you have a collective effort, you have multiple brains that will also bring multiple ideas and make something better at the end. So today, Fatos can give maybe some more words on that. You can purchase of renting an artificial intelligence on the internet or on the dark web, depending if you're on the white side or on the black side. Having said that, we should, on the white side, do the same by having as broad and larger collaboration as possible to reinforce our models. And this is exactly what you experience yourself, Ahmed.
Yes. Firstly, machine learning and AI is learning by going. For example, if you are taking in a normal non-machine learning, if we are talking on a normal web application firewall, WAF, it is simply working in application level. Okay. Before putting this device behind the application, it passes learning mode. Learning mode is define what should this device do, what should not to do, and what's the behavior, what is accepted. If the learning mode phase is performed successfully and cover all test cases and all use cases, then when it turns to blocking mode, it will be pretty good. It will be pretty controlled. If not, and if learning mode is a bad behavior instead, and there is no configuration review or some review on the profile, it will be a nightmare. Sure, and machine learning is a continuous development. It's not an algorithm which is developed once and then we will go home. Actually, not. It should be tuned and it should be reviewed by a frequency that we notice, that we know there is a change. It should be reviewed by every single change in order to take the efficiency. I think.
You have a follow-up question to that as well?
Yeah, the other question was regarding the automation part, because do you think at some point, and the way I see the excitement in people, embracing AI and machine learning, do you think at some point we're going to have a problem where people will stop having jobs because they've taken brains and put together and then transferred it to, some imaginary person that will be doing the job for us,
Mhm.
and then what will be the consequences on the job for people looking for jobs?
Yeah. Okay. First, I want to maybe address this misconception that AI today is built after how brains work. We still don't know how brains work in terms of intelligence. Right? There's a huge gap in knowledge in that space. There are techniques like backpropagation, which is one of those techniques that is used within machine learning algorithms that somehow mimics some process of how synaptic nerves work, but it's not nearly as close as that. And also, AI today is focused on solving very narrow problems. Speech is a very narrow problem. Vision is a narrow problem. Language is a narrow problem. AI is really good at targeting specific narrow problems. And if you have enough training data for that narrow problem, you can build some accurate, very accurate model that can work within the scope of that narrow problem. The moment you fall outside of that scope, and the moment you give the algorithm some sort of input data that does not follow the training data that was used before, the algorithm will fail, right? And this is one way that attackers can use to fool algorithms today. For example, if there's an algorithm that detects whether a transaction in a bank is fraudulent or not, and that algorithm was trained on a lot of customer data involving their demographic information, their previous historical transactions, their address, etc., etc. And now you give the algorithm observation about a customer that says, okay, this customer is 125 years old, and is from Australia or Mars or something like that, and the algorithm hasn't been trained or hasn't seen that type of information before. That falls outside of the distribution of the previous training data, so you might fool the algorithm to think that this actually is a person that could commit fraud or not, and he might mess up the algorithm away a little bit. So that is a term we refer to that called adversarial machine learning, which is used by attackers today to fool machine learning algorithms. Now, I don't think, of course, there's dangers of using AI today in the industry, and there are dangers of some jobs being automated. For example, when it comes to contact center work, I work with a lot of customers that want to automate some of their contact center functions. And what I mean by automate is they take most of the laborious tasks that are, for example, asking the customer when they call the organization repeated questions like, what is your phone number, what is your name, where do you come from, what's your complaint. These are very repeatable, labor-intensive questions that you don't need a human to perform. You need the human to be present in activities where the human cognitive functions are most used and best used, not just for repeatable tasks. So what we're doing now is we're saying, okay, let's automate some of these very repeatable tasks and let the human focus on more meaningful tasks. Maybe understanding why the problem arose, where it came from, how do you then transfer the customer to the right solution, to the right department. These are stuff that machines are not perfect at the moment. But we are heading that way. There is a danger. It's a double-edged sword, right? One way is, as I mentioned earlier, the definition of machine learning is an ever-optimization process, meaning that organizations are looking for optimizing these algorithms for very specific tasks in an ever-increasing fashion, meaning that these algorithms will get better and better and better and better doing things that they do at the moment. And we will see more and more things being automated, but we will also see more creative jobs coming into the marketplace where humans will play the best part of using their cognitive abilities.
So no call centers will disappear then?
Potentially.
People that were supposed to be hired in call centers will disappear, and there will be jobless people.
Or they will be let's say repurposed for other areas, right? Even in medicine, right? You have now diagnosis algorithms that can diagnose particular diseases much better than, let's say, a surgeon. But we're not saying let's replace the surgeon. We're saying let's work in complement, right? Complementary to the surgeon. So the surgeon makes the final decision, but there's an AI technology that could actually aid in that process, which is a fair use of AI.
Cool. Thank you very much.
My father was just done 2 days ago by a robotic surgeon.
Mm.
I think AI is a real marketing issue. That's one of the main problems.
Yeah, but I guess it's maybe a reflex, right? I mean, yeah.
I'm a big fan of Army.
Yes?
Thank you. You had an example of a credit card potential fraud that the user never cashed out the card, and then all of a sudden he cashed out, and then probably it's a fraud. This means that there might be some machine learning behind this, right? Learning the user behavior. Yesterday we had a quite hot discussions on the privacy. So do you think that machine learning will jeopardize privacy? Because you don't know who is on the other side of your solution. So you have to treat the person as an attacker potentially, zero trust, and monitor all the activities. And this, me as a user of this technology or bank customer, I would know that bank is monitoring all stuff I do, and goodbye privacy.
I don't think so, as bank is already eligible to monitor all transaction and monitor all activities that performed by each customer as a part of its liability. It is not monitoring for breaking your privacy, but it is liability as a bank owns your money. If this activity is not performed, there will be huge issues. It will be a real financial loss. Fraud system which had the good machine learning and AI and behavior analytics support the role of monitoring and saving money. It is not against the privacy at all.
Cool. Christian, maybe you have something to add in that regard?
It's two things that pop up into my brain. The first one is I had a typical that kind of an example of uncommon behavior. A friend of mine who wanted to purchase a pretty expensive computer at Dell. So he made a bank transfer, and the bank transfer was blocked because the amount was so huge to Dell that it was blocked. And it was about 25, 30 years ago. So we didn't even spoke about AI at that time. So it was a human behind that behavior who says, ooh, let's block it and first call the customer to see what happened there. And to me, I can even see the other way around, AI just reporting. There is something strange that without any human intervention, so decreasing the risk of data privacy because nobody has access to, human meaning, has access to what happened, up to the point the red flag is raised and the customer is called by some human that knows there is something wrong, but I maybe don't know what exactly is happening. So you can balance that in one way around or the other one, depending a bit where you put the limit on the data which is communicated. But as Hamed said, you're tracked anyway for all of your banking transactions and activities. So
I would say in machine learning specifically, we use quite a lot of techniques when it comes to training models to mask a lot of the sensitive PII information that customers have. Also, whenever we deploy models, we use responsible AI principles so that these models are following certain guidelines when it comes to making sure that fairness is embedded into algorithms and making sure that the training is not biased in one way or another. So there are mitigation strategies that we are using today to make sure that any model is deployed using responsible AI principles. Another angle to this is something called privacy-preserving ML, which is a space within machine learning that allows you to train models without bringing the data from one place to another. Think of it as a health or a financial bank who has, let's say, regional presence, multi-regional presence. Let's say they have presence in Germany, they have presence in Taiwan, they have presence in Egypt, and they want to train models across all these regions. Instead of bringing all the, let's say, data from Egypt to, let's say, their center is in UK, they can actually train the model locally in Egypt without bringing it using this technology called privacy-preserving machine learning, which is something called also known as federated machine learning. So there is lots of techniques out there today that exist to mitigate around that kind of concern.
Yeah, on the topic of, on the topic of whether or not AI will support cyber attacks or support cybersecurity, I would venture that probably the opposite will happen to begin with. Not because the technology itself is not mature, but I think the people are not mature. Like the implementation aspect of the technology has still a long way to go. You know, for instance, upper management might provide some financing for a department to develop an application, and then the developers realize, okay, this is too much work for us, we'll source that to another company, or we'll implement some form of processing outside the company. And if management is not aware of the privacy issues, then that's creating compliance risks, and potentially risks of, once you outsource some of your technology to other providers, then you're opening, the threats are open. Threats to the data assets are brought in. And another thing about privacy is it takes a lot of education of the users or the implementers. For instance, French data protection law makes it a requirement for implementers of AI to be able to explain to end users how the algorithm works. And I'm pretty sure to date, very few companies have actually trained their customer support teams to explain in simple terms how, the risks of the technology, how it works, so on and so forth. So could you reflect on the maturity aspect of the technology, not so much from the technical perspective, but from that of the mindset of management, I would say?
Go ahead.
I need to answer the second part first, regarding how institution or companies can introduce AI to their end user. The most known way is to name the service itself, like the interactive support robot. For example, Amazon AI called Alexa, Siri for Apple, and some other stuff like that. So it introduced as a product or as a new service. But after all, its services are common as an interactive supporter. So the customer is happier to deal with something he knows he's not a human, and gaining answer and then ask an advanced question from his point of view and getting the correct answer. So it need to study the culture of each customer segment to deliver the right product context. Thank you.
Any other questions? All right. One of the to go back to the theme of preventing cyber attacks, during our pre-panel discussion, the topic of adversarial machine learning came up, and the capabilities in that regard and the great potential. Maybe you could step in and
sure,
you're
yeah.
the one that brought up the subject.
Maybe I'll just briefly give an example of what adversarial attacks mean. Actually, everyone knows what a Tesla car is today, obviously, but so think of it. Tesla cars rely on machine learning to detect objects in real time as they're driving. So they're looking at the scene in front of them. They're looking at objects, people, stop signs, locations, etc. They're also using sensory information. They're also using satellite information. All of this is inputted into the model in real time, and it's able to make those quick decisions that typically a human driver would make. Those models that Tesla uses are a class of models called deep learning models, which today are really easy to fool using perturbations technique or adversarial attacks, as the other term suggests. And what that means is, for example, you can imagine a person wearing a t-shirt of a stop sign and then just walking through the street, and then Tesla car will see that person and he will think it is actually a stop sign, and he will stop in the middle of the road. So that could be an adversarial attack because the model itself understands that object to be a stop sign rather than a person. Of course, Tesla has been asked this question before, and they have techniques to circumvent around that, but this is just one very simple example of what an adversarial attack is. Now, if you bring it into the context of cyber threat, cybersecurity, an adversarial attack is a threat actor using, let's say, training input data to fool a model into thinking that a fraudulent transaction, for example, is not fraudulent. And that can bypass internal algorithms that normally would detect it, and treat that, let's say, fraudulent transaction as non-fraudulent and just normal. And there you go, you have a transaction that potentially has, infiltrated loads of cash sums into the bank without the bank realizing it, which could ultimately affect the bottom line of the bank itself. But that is one way you can use adversarial machine learning today to benefit the attacker and sabotage the network and the algorithms of a defender. So that's just one example.
Cool. Christian?
I'm pretty much sorry to be on this side of the table right now, because what you just say, I do have a question to you then.
Cool.
Go ahead.
What you just said with Tesla and popped to my mind, what about deep learning and predictive learning? How is that now potentially affecting also your privacy? Because then it's nothing based on what you are doing, but what you could do. So you are considered as potentially guilty before you do anything.
Yeah, I mean, we had this issue in the US when I think there was the US Federal State Department there deployed an algorithm that could predict whether somebody had inclinations to be a criminal or not, and that backfired massively, and it was leveraging facial recognition software to identify criminals based on their facial features, and the algorithm was trained in such a way that it could not, let's say, there was a lot of bias in the data based on, let's say, the racial types of the persons in the data set. It was able to discriminate against one group more than other groups. And it was obviously decommissioned completely. It would backfire. So those are the kind of things that we need to, let's say, mitigate against by using data bias techniques. So you can train, for example, today on data sets that are normalized to handle disparity in different classes. For example, gender disparity could be one, racial disparity is another one, location disparity is another one. So you can put all these techniques into place before you actually deploy a model and keep that in production to preserve discriminatory predictions, but also privacy of users as well. Yeah, I mean, these are challenges that we are seeing in the sector, and there is techniques, to answer to the gentleman's question over there in the third row, around explainability that help us to understand the predictions of these algorithms before, so that an analyst can actually understand those, not just a machine learning engineer or data scientist. And we use those techniques all the time to understand why an algorithm made a decision the way it did, and what were the factors that contributed to that decision, what dimensions, what features did the algorithm use to, let's say, classify someone as being criminal or not. Hence, how we can arrive at let's say, either allowing that algorithm to be deployed in production or decommissioning it, which happened. Another very important factor I want to mention, I think is really important, is today is ever more important to ensure that the teams develop these algorithms are diverse teams. By diverse, I mean you have representatives from, let's say, culturally, but also representative from different backgrounds in terms of expertise. You need to have these teams in place, otherwise machine learning development is not going to be as effective as everyone would like to be. That's it.
Cool. Christian, Ahmed, anything to add in that regard?
Perfect, thank you.
No. Christian, was your question answered?
No,
Okay.
I'm happy. Thank you.
Yes, please. I think we have time for one more question.
You spoke about predictive algorithms, etc. This brings me to the reflection or a question about who is the party that is mastering ML and AI. Because as you know, for example, where predictive algorithms are very important, for example, for some industries, some financial industries, you know that the top of the predictive algorithms that works on huge data centers is BlackRock today. BlackRock is even more powerful than states. You know that BlackRock, after the crisis of financial crisis of 2008, are hired by European Central Bank to help them
to reorganize procedures of financial institutions, etc. So today, who is the sector that is mastering, that is on the top of mastering AI and ML? Armies, Department of Defenses, states. Have you got GAFA, Microsoft, and so on? Have you a clue about it? Who is mastering that? Because I think that the sector or the party that is mastering that will master many things in our future.
I would say, I wouldn't use the word mastering. I would just say each company, each sector specializes and masters one area of AI better than others. But they're all leveraging pretty much similar techniques when it comes to machine learning in its own right. I would say there are some sectors who are seeing more use cases with AI than others. For example, retail is one of them. And then, of course, when it comes to GAFA, you mentioned some of those companies. I think the companies that are setting on huge stacks of data are the ones that are innovating the most and have the most power. Think of Facebook and what they did with Cambridge Analytica, for example, which is a prime example of this. If you're setting on all that social data, the power you have socially to control social dynamics, geopolitics, politics in general, is quite scary, and everybody should be kind of conscious about that. But again, it depends on how you're measuring mastery. Are you measuring mastery in terms of, predicting health diseases? Are you measuring mastery of being the best in predicting market trends in terms of stock trading?
Modeling and how to build sophisticated algorithms in order to address many cases of
yeah.
AI.
Yeah, I mean, companies like OpenAI, DeepMind, DeepMind, for example, is a prime example of that. OpenAI is another one. These are huge research departments that have a lot of the best brains in the world when it comes to researchers working on AI. You saw what DeepMind did with their AlphaZero, who beat, Sedol in the Go champion game, 5-1, which was incredible achievement. But you have, as I mentioned, you have these research departments within these GAFA companies that have the best and brightest people working on the most sophisticated AI models. But again, it all comes down to how you're deploying and how you're using them in practice.
I need to add a small part. AI and machine learning is not about spying or not about knowing something you really don't want the institution or the entity to know. At the end, all of this stuff are bounded by the liability and bounded by the agreement, consent, and many governance control to govern what should the institution do and what shouldn't do. It is not about institution. It is not about spying. For example, army or federal entities or some institutions, some governmental institution. All of us know that there is a surveillance cam all around the city. So most probably we are footage by each step. It is known. It is not something hidden. There is something. There is no something bad inside, but all this data are used when there is something happened, and they force the institution to use all this data. Thank you.
Christian, do you have a final word in that regard?
My final word will be, as for a human being, AI should be collaborative as much as possible to reinforce and will never prevent you to have a backup plan. Ahmed, your final word.
Folks, we've run out of time. I thank you very much for your very active participation during this session. It is greatly appreciated, and hopefully we addressed at least some of the questions you may have had coming in. And personally, I hope that maybe you have a few more questions leaving the session, which is always a healthy thing. Thank you very much. Thank you very much to our panelists. Feel free to approach them afterwards, and have a great rest of the day.